responsible for knowing these functions inside out. You have to draw a graph given the equation, as well as be able to write the equation given the picture of the graph. We're going to use the graphing calculator today to help us do that. But when you have to do these, you need to be able to do them without a calculator. In the first one, hopefully we don't need to type into our calculator. It is the identity function, f of x equals x, or y equals x. And actually what it looks like is it goes from the lower left-hand corner to the upper right-hand corner and through the origin. And hopefully your picture is a little bit better than mine. Do the best you can. If you really want a ruler, I have some here that you're welcome to borrow. But that's the only one that you'll really need it for. So in terms of key points, I said -10, -10, 0, 0, +10, +10. Those might not be the best points, but the way I do describe the identity function is from the lower left-hand corner of the graph to the upper right-hand corner, and the lower left is -10, 10, and the upper right is 10, 10. The question is on this one is, what's the domain of a line with a slant? And if you have to guess, and it doesn't even sound like you had to, all real numbers. And I'm going to write in interval notation. If you want to use some other notation to indicate what it is, that's fine as well. There's your symbol, another symbol for all real numbers. Probably eventually I will ask for the interval, but these are your nodes. What's going to make the most sense to you? And the thing is, the domain for this function is all reals as well as the range. The question is this function even, which means symmetric over the y-axis, odd, symmetric with respect to the origin, or neither? It's odd. We've got completely negated points. And it is symmetric across the origin. Is the function 1 to 1? What's the test that we use to test for 1 to 1? It's horizontal. Is it 1 to 1? Yeah. Now, we could have typed that in the calculator, but we'll type the next one into the calculator. And the next one is the square function, also sometimes known as a quadratic function. If we come into our calculator, we go to y equals, and we type in x squared. And we look at the picture. Hopefully, we basically know what it's going to look like. But more importantly, let's get a couple of key points in this graph. So let's go to second in table. And in terms of key points, I'm going to say -2, 4, -1, 1, 0, 0, +1, 1, and +2, 4. We've got 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. And there's the picture of our function. Is the domain still all real numbers? Yes. X is allowed to be anything. But the range is not all real numbers. And when we're looking at the range, we have to ask ourselves, do we have a high point or do we have a low point in this graph? We happen on this one to have a low point on the graph. Our lowest point in the y values, because the range is represented by the y's, is 0. So our range would be 0 to infinity, 0's included. For some of you, you might prefer y is greater than or equal to 0. this function even, which means symmetric with respect to the y-axis? Odd, symmetric with respect to the origin, or neither? It's even. We can fold this graph on half, and one half will land directly on top of the other. Is our function 1 to 1? No. I'm going to pause the video for a minute. In the cubic functions, domain is all reals, range is all reals. It is an odd function. We have the point 1, 1 on the graph, and we have the point negative 1, negative 1 on the graph. We have the point 2, 8 on the graph. We have the point negative 2, negative 8 on the graph. And it is also 1 to 1. Quickly, the quartic function, it looks like a parabola. It's not really. If you look at the points, the 0, 0 and 1, 1 and negative 1, 1 are all there. But then it's 2, 16 and negative 2, 16. So it's a little bit tighter in there. The domain is still all real numbers. In the range, we have a low point of 0 and continues on forever. It is an even function. We're symmetric with respect to the y-axis. And it is not 1 to 1. We fail the horizontal line test. Again, on the absolute value function, to type it into your calculator, you use the math button. So your y equals, then you go to math, and then num, you have to arrow over to number, and then it's the first function on there, ABS. Our domain is all reals, and our range is all reals. And then it is an even function. It's symmetric with respect to the y-axis, and it's not 1 to 1. So I had a mistake on the range, so let's look at this. Our domain is all real numbers. X can be anything. But we need to ask ourselves, do we have a high point or do we have a low point on the graph? We actually have a low point on the graph here at 0. And it's going to continue on forever. It is included. 0 is part of the graph. We are still an even function. We're symmetric with respect to the y-axis, but we do fail the horizontal line test. The function is not 1 to 1. So let's type in y equals 1 over x. So we can go to alpha, y equals n1 divided by x. And we can look at our picture here. Looks something like that. But really, we're going to have to draw it on our paper, so let's go to the table. And let's get a couple of key points, and I'm going to scroll down a little bit. Too much now. But what we see on here, as I copy down these points, is we see an error. And that's going to be important in a problem. But what we've got is we've got negative 2, which gives us negative 1/2. We have negative 1, which gives us a value of negative 1. At 0, we get A. And then we have positive 1, positive 1. And when we have 2 for a value of x, we end up with 1/2. That error there signifies that x is not allowed to be something. So we got an error at 0. That means that our domain can be anything but 0 for x. So if we draw our picture now, we get negative 2, negative 1/2, negative 1, negative 1. We get that. And then we've got 1, 1, and 2, 1/2. There's our reciprocal function, 1 over x, 1 divided by x. in actuality, what's happening here is that our graph is never going to touch the y-axis, but it's also never going to touch the x-axis, which means that we have asymptotes there. And also, because it doesn't touch the y-axis either, we can say that our y value can be anything but 0. And then, the rest of it is fairly straightforward. Is our graph even, which means symmetric with respect to the y-axis? No. Is it symmetric with respect to the origin, which is odd? And if we look again, we see -2, -1/2, and +2, +1/2. The points are negated completely. -1, -1, +1, +1. That means that we are going to have an odd function. And is our graph 1 to 1? Well, it does pass the horizontal line test. So yes. Square root function. So the goal of these here by Friday is to know them without using your calculator. But let me just tell you how I think of this, because I know that I know how to draw the graphs. But here's what I'm thinking when I do this. I think, well, what's the square root of 0? 0. What's the square root of 1? 1. Can I take the square root of 2? No. Can I take the square root of 3? No. Can I take the square root of 4? Square root of 4 is 2. Can I take the square root of 5? No. Can I take the square root of 6? No. Can I take the square root of 7? No. Can I take the square root of 8? No. Can I take the square root of 9? Yes. It's 3. So we can type that into our calculator. But here's what the picture is in terms of some key points. 0, 0. 1, 1. 4, 2. Square root of 4 is 2. 9, 3. Square root of 9 is 3. Again, on this problem, the domain and or the range are not all real numbers. And we need to look, do we have a starting point on this graph? And it starts at the origin. And it actually starts at 0, and it goes right, which means that our domain is 0 to infinity. X is greater than or equal to 0, if you prefer. And it's also in terms of, do we have a high point, do we have a low point on the graph? It actually, again, is 0. Our range is going to look exactly the same. 0 to infinity. We start here, but we continue to go up forever and ever. Is our function symmetric with respect to the y-axis? No. Is it symmetric with respect to the origin? No. This graph is neither. But is it 1 to 1? It is 1 to 1. And you can type that in and look at that on your calculator if you prefer. The cubed root function, again, I approach it the same way. It's one of my favorites to draw. But if you need to, remember math is the function. Or if you're using the Inspire, the same button that you use to get the absolute value. It's the cube root of x. Looks like that. And when we do this problem here, we can look at the key points there, which I need a few more. I don't think I'll scroll through it. I'm pressing my luck as it is. But it's 0, 0, 1, 1, 8, 2. negative 1, 1, and negative 8, negative 2. So it's negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, positive 8, positive 2. Does that graph remind you of anything? Well, if we go back here to our cubic function, looks kind of similar, right? Cubing and cube root are inverse operations. So if we know what the domain and the range of this function are, please stay with me. I know it's hard. Our domain and range are also all real numbers in this function. Is this function even, odd, or neither? It's odd. Again, notice that the points completely negated. Negative 8, negative 2. Positive 8, positive 2. Negative 1, negative 1. Positive 1, positive 1. And we can kind of see the symmetry there, I hope, as we look at the picture. Is this function 1 to 1? Yes. So, exponential function. F of x equals e to the x. I want to show you where that button is on your calculator. Going back to y equal and clearing. I might need to look on the Inspire if you don't know how to do it or don't remember it from Algebra 2. But the E button that I'm going to use is going to be second and ln. So that gives me E with an exponent. There's also an E on the division bar here. But let me know on the Inspire. I can't remember how to do it off the top of my head. I don't think it's that difficult. But if you don't know how to do it, let me know. So this one's going to be e to the x. And when we go and look at our table here, we're going to get a couple points. And they're not going to be very pretty points. In fact, I'm only going to take 3 of them in terms of the key points, which are 0, 1, and 1, 2.7, and I have to look at the third one, which is 2 and 7.4. And we can draw that picture, although let's look at the picture in our graph as well, just to know what it looks like. Looks like that. So that gives us a good idea of what to expect here when we draw it. 0, 1, 1, 2.7, 2, 7.4. And again, what we have in here is we have an asymptote. If you really look at the graph, or if you really look at the table, and we start scrolling through on these y values, they keep getting smaller and smaller. We've got 0.04, 0.01, 0.00, 0.00. This is 0.0009. It's in scientific notation. We're getting closer and closer and closer to 0, but we're not quite touching. But the thing is, x can be a positive value, x can be a negative value, x can be 0. Our domain is still all reals. And in terms of do we have a high point, do we have a low point, we have a low point on this one. And in terms of interval notation, it's 0 to infinity. I'm going to put 0 in parentheses. It's not part of this. If you prefer, it's y is greater than 0. There's not an equal there. We do not touch the x-axis. When we look at our functions, we notice that the graph isn't symmetric with respect to the y-axis, so it's not even. Not symmetric with respect to the origin, so it's not odd, which means that it must be neither. But is it 1 to 1? We passed the horizontal line test, so it is. To finish, I want to jump down here to the bottom function. We'll come back to the other one later. We'll come back to logarithmic function later. Well, let's type this one in, and if you remember on the calculator, the button that we typed in to get to the e function, I did second ln. So when we clear this one out, what we're looking at in terms of our picture is we're going to graph ln of x. And let's look at what this looks like. So it's similar to what we were just looking at. And if we go to our table here, got lots of errors there, but let's get a couple of values down here that might be a little bit better. So we have 1, 0, and 2 and 0.69. Again, when we go back and look at the picture, just to help us draw the picture, remember that the calculator, it has a limitation in terms of pixels. But we've got 1, 0, and we've got 2.69. Looks something like that. Well, if you think about it here for a second, what happened here on this one is we're looking at the inverse function of our e to the x. So our domain from this function was all reals, which means that our range for this function is going to be all reals. If we go back to that function on the top page here, f of x equals e to the x, the range is 0 to infinity. So our domain is going to be 0 to infinity, not including the 0. And this function is neither even nor odd. Is it 1 to 1?